10.5 Trigonometry and Area. The beginning of this section is actually a review for us. I've been having you do this throughout our time working with the formula for area of regular polygons. When we use trigonometry within the problem to find maybe the apothem or the side length, that was what was supposed to be partially introduced in this section. But like I mentioned, I've had you doing that already. So the first couple of problems, I'm just going to have you attempt, and I will talk through after you've submitted an answer as just a little bit of a review. Now, when you do these first couple problems, please remember that we don't want to round anything until the very end of the problem. And that is when we will just type everything in our calculator and round one time to the nearest thousandth. So your first problem is to find the area of a regular pentagon with 8 centimeter sides. So within this problem, if we know we have an 8 centimeter side and we draw our isosceles triangle picture, that 8 centimeter is that base of that isosceles triangle. We have to find a central angle by taking 360 and dividing it by 5 because we have a pentagon. And then we take half of that central angle to find one of the acute angles within one of these small right triangles inside of our isosceles triangle picture that we draw. So we have to remember the base is bisected by the apothem. So that's why I have the 4 and the 4 written. We also then have to find the apothem, and that takes trigonometry because we only know one angle and one side. We can't do Pythagorean theorem. We don't know, actually we know for sure that it's not a special right triangle. So we have to use either sine, cosine, or tangent. And in this case, it's tangent. So we set up the tangent of 36 equals 4 over the apothem. Now again, we don't want to round until the very end. So that means we're just going to write that the apothem is 4 divided by the tangent of 36. And we're going to keep that, plug that into our formula, and then type everything into our calculator at once to get the most accurate answer. So here you can see everything that was used. 1/2 times 4 divided by a tangent of 36 times 5 times 8 should have given us 110.111 square centimeters. The second problem is to find the area of the regular octagon with perimeter of 80 inches and give the area to the nearest thousandth. This problem is very similar to the first problem in that you are actually given the side length. You do have to do a little bit of work to figure out that the side length is 10 since you were given the perimeter. And then again, you have to find the apothem using right triangle trigonometry. And again, we want to make sure we're not rounding anything until the very final answer, which should have been 482.843 square inches. Now, the new part of this section comes in another way of finding the area of a triangle. So let's say we have this triangle given to us here in number 3. All we know is the measure of angle A and the lengths B and C. So if we think about area of a triangle, we know that that is the formula 1/2 base times height. So if we plug in everything that we know, the only thing we would have out of that is the base. This B, the side length labeled B, is the base of that triangle, with H being the height, but we don't know what H is. So what we have to do is we have to think about the fact that we know one of the angles. We know angle A, and we know that we have side length C as well. So this right triangle on the left portion of the original triangle here, we could actually calculate that height using the angle measure that we know and the side length that we know. This again involves right triangle trigonometry. We'd be able to set up that we know the sine of angle A is equal to the height over the side C in this case. So now what this results in is, because we know side C and we know angle A, the height would be those two values, C and the sine of A, multiplied together. And that's what we're actually able to plug in for h. We're just using substitution. And there would be how we could actually find the area of the triangle when we originally don't know the height. Now this leads us to the formula here in number 4, how we're able to find the area of a triangle when we're given two sides and the included angle. So within the triangle any triangle that we're given, notice how sides opposite from angles are labeled with the same letter. The angles are capital letters and the sides are lowercase letters. So let's say we first draw in all 3 altitudes. Now, depending on what information I'm given, I could write 3 different formulas for the area. I could write these 3: 1/2 BC times the sine of angle A, 1/2 AC times the sine of B, and then 1/2 AB times the sine of C. So all that really is determined by which sides and which angle I have information on within this triangle. But now that can get kind of be a lot to remember. So what I've done is I've tried to make it a little bit more generic for us. If we call this formula 1/2 times side 1 times side 2 times the sine of theta, this will suit any of our triangles that we will come across. The biggest key to being able to use this, if side 1 and side 2 are different, two sides of the triangle, the key here is that theta, your angle, must be the included angle between those two sides. So when we go to use this, in number 5, part A, we notice here we have 2 sides of a triangle and we have the included angle. So we would need to start out with the formula area equals 1/2 side 1 times side 2 times the sine of theta. Now we just plug in our values. So 5.5 and 12 go in for side 1 and side 2. It does not matter the order. And then we have the sine of 33, again, because we know the theta angle has to be the included angle. So when we put that all through the calculator and round it to the nearest thousandth, we find that the area is 17.973 square feet. In part B, we again notice we have side lengths, we have angle measures, but we don't have a right triangle, so we don't have a height. This is again a time where we would need to recognize that we are using the formula area equals 1/2 side 1 side 2 times the sine of theta. The issue here now, remember there are little extra note up in number 4 where we originally found the formula. Theta must be the included angle. So we have to do a little bit of work to find that included angle. We have to take 180, which we know is the total for a triangle's angle measures, subtract the 2 angles that we know, and we would find that we have a 40-degree angle as the included angle between the 104 meter and the 226 meter sides. Now we can substitute those values in. Again, we didn't know originally what the angle was, the included angle, but now we've found it so that we can put 40 in for theta. And then putting that all in the calculator, we would find that the area is 7,554.040 square meters. Okay, now I'd like you to read through number 6 and find the area of the plot that is described here. So here we're told that we have a triangular plot and we're given 2 side lengths, and then we're told that the angle between them is 71 degrees. It's another way of describing what we refer to as the included angle. So we would be able to use the formula 1/2 side 1 side 2 times the sine of theta. Plugging all of our values in, we would have 75,183.855 square feet for our area. The next one, again, I'd like you to read through it and find the area of this park in this case. So again, we were able to use the formula area equals 1/2 side 1 side 2 times the sine of theta. The wording in number 7 is a little bit different, but it still describes an included angle between the 200-foot and 300-foot sides of this triangular park. So that answer for the area in this case, because if you read the problem correctly, says round to the nearest 100 square feet. The correct answer, based on the problem and the way it's worded, would be 27,200 square feet. Now I would like you to go ahead and do number 8. And number 8, we're going to talk about in class because there are some things I'd like to make sure we all are aware of. So we'll discuss that together. And then you will be finished with this set of notes.